So our first problem is Jack and Kim each improved their yards by planting geraniums and hostas. Hopefully we're getting to where when we see two people and two things, you think systems. So this is going to be a system of equations problem. More times than not every time, but more times than not, your word problems are going to be solvable by elimination. There's usually one on the calculator inactive section, and there's usually one on the calculator active. So as long as we can set up the equations, the calculator active, you're going to plug it into your Desmos that's going to be embedded in your test, and you're going to look for the intersection. Once you get the equation set up, that will be your job. There's no way around that. So they bought their supplies from the same store. Jack spent $84 on 9 hostas and 6 geraniums. Kim spent $63 on 8 hostas and 3 geraniums. Find the cost of 1 geranium. So what are the 2 things that we're counting here, or the 2 things we're discussing? Can you tell me one of the things we're discussing? Thank you. So we have hostas and geraniums. Now, like I've said for those of you who come a lot, I would use H and G. If you're going to use Desmos, you want to use X and Y. So you just decide which one's going to be X and which one's going to be Y. I've said this before, but I can't say it enough. I would really highly recommend making a little chart on the side that says hostas X, geraniums Y. So that way when you're finished, you can think about which answer you're going to have. Because if it happens to be multiple choice, they're coming for you and both answers are going to be there. So we have Jack and we have Kim. Jack bought 9 hostas and 6 geraniums, and he spent $84. Kim spent $63, and she bought 8 hostas and 3 geraniums. Now, again, if this was calculator active, you could go plug both those in just like that, but with X and Y, and go find their intersection. And then remember that X would be whichever one you assigned X to, and Y would be whatever you assigned Y to. For practice purposes, if I was inactive, because it's not a terrible, so no calculator, I'll need one of these to cross out. So that means the number needs to match. I just need a positive and a negative of that number. 9 and 8, honestly, with no calculator, that's going to be big ugly to get those to match. You could multiply the top by 8 and the bottom by 9 and make one of them negative, top or bottom, your choice, but I would not recommend doing that with no calculator. 6 is not terribly hard to make that 3 match. How can I turn 3 into a negative 6? Times it by negative 2. So this whole second equation, I'm going to multiply by negative 2. So 60 times 2 is 120. And then that 3 times 2 is going to give me 6. And I'm just showing you how this could easily be inactive. So 3g could now become a negative 6g, which is what we're looking for. 8 times a negative 2 is going to be 16h. That's our new equation. We're going to put our old one that's above it, the other guy, back with it. And you're going to work straight down and add. So it's negative 16h and a positive 9 gives me what? Negative 16h and positive 9, when I add those together, gives me what? Yep, so negative 7h. Our 6's give us a 0, which is good. That's what we're shooting for. Negative 126 and 84. So that's 126 and 84. That's a negative 126, but I'm going to subtract the 84 and then just tack on the negative because I owe you 126, but I pay you 84. Should be 42, but it's got to be a negative 42. Again, showing you how this could still be calculator inactive. So if they're both negative, I'm going to divide by 7. And how much are hostas going to cost? What's 42 divided by 7? And if division freaks you out, what am I multiplying 7 by to get 42? 7 times what gives me 42? 6, right? And I have a negative and a negative, so that gives me a positive. So hostas are going to be $6 each. That is not what it's asking for. It's asking for geranium. And I remember being in the classroom giggling because I could get people to where they could get to this perfectly fine. And then all of a sudden, when they had to solve for geranium, we had a mess. Like when you had to go plug it back in. So my piece of advice is just to slow down and do the best you can. I'm going to use the second equation because it is the smaller numbers since I don't have a calculator. So 8 times 6, because H is 6, so H is 6, plus 3G equals 63. And I'm using the original equation. What is 8 times 6? Good, 48. Plus 3G equals 63. We're going to solve for this 3G. Line of great divide. What are we going to move first? It's inside the box, so we want to work outside the box first. You're looking at the right side, though. But we're going to move that 48. It's positive, so how are we going to move it? Subtract 48. Right. Everybody ignores my boxes, but I do that box in the stinky kid. And anybody outside, you want to move first, then you'll get off whatever's attached to the stinky kid. So these guys are gone. And now I have 3G equals to 63 minus 48. Again, with no calculator, I would go ahead and do real math where we count them out. 5, it should be 15. Yep, 15. And then how do I get that 3 off that G? Good job, Emma. You're faster than me. That is 3 times G. That is the multiplication. Yep. How would I undo 3 times G? Divide by 3. Yep. And so G is going to equal 5. And that's the answer to our question. Geraniums are $5. Right? Geraniums are $5. Hopefully some of this is, you're starting to see a pattern. It's not too hard. Okay, so this was a lot prettier when I made it on the page and it didn't print very well. I'm sorry. Ideally, you will have great graph paper. I was just trying to help us out a little bit. M is the midpoint. So the midpoint is 5, negative 2. So 1, 2, 3, 4, 5. 1, 2. This is my midpoint. And L is 3, 6. And M is the midpoint of KL. I'm going to draw this on another sheet of paper because I don't want to make this more confusing for no apparent reason. So give me 1 second. So this is our 0, 0. We're going to go to 5, negative 2. 1, 2, 3, 4, 5. That's our midpoint. And then our L is 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. This is L. Now, you can find the other endpoint algebraically, or you can graph it. But to find the other endpoint graphically, you have to figure out how far these are away from each other anyway. So we went 2 over 1, 2, 3, 4, 5, 6, 7, 8. And so you're just going to repeat that exact same. So from 3 to positive 5 is 2. And then from 6 to negative 2 is 8, if you think about it algebraically. So we're going to go 2 more over. So 5, 6, 7. So we're going to go here. And then down 8. 1, 2, 3, 4, 5, 6, 7, 8. And that is going to be K, I believe is what they were calling it. KL. Yep. Okay. And that was from 7. And then if I go down 8 from negative 2, that's going to be negative 10. So 7, negative 10 will be our answer for that guy. And that's if you did it graphically. Biggest thing is, again, slow down. Make sure you're reading and making sure you're putting your M at the midpoint and you don't go the other way. Because this, it says, is the midpoint. So it's in between the other two. Very important to make sure you're reading and paying attention to what you're doing. Algebraically, just so you can see it, remember it's x plus x divided by 2, y plus y divided by 2 is my midpoint. My midpoint x is 5. I have another x for L, which is 3, and then my other endpoint is not there. My midpoint y is negative 2, My other y that's given is 6. The y of the other endpoint is missing. So divided by 2. This is a great practice. If you don't want to solve this way, that's fine, but we're going to practice solving two-step equations. So looking at the 5 equals 3 plus x divided by 2. What would you guys do first to get this x by itself? This is one big box. We got a big hot mess over here. So we got to get rid of the first thing first. What's that going to be? Or what do you dislike the most about this equation is usually how I can get you to start in the right place. The division is a problem, right? That divided by 2. Gross. Don't like it, right? So how do we undo division? Tristan, talk to me. Proof of life, buddy. You don't talk by person, but you got to type in. We're going to multiply. What are we going to multiply by? Good. We're going to multiply by 2. Multiply by 2. So that gives me 10 equals 3 plus x. Beautiful. We got our x. We got our great divide. What are we going to move now and how are we going to move it? Good. We're going to subtract 3 from both sides. So x equals 7. All right, we're going to do the same thing for our other one. We have a 2 in the denominator. So it's divided by 2. We undo division by multiplying. And that's going to give me a negative 4 equals 6 plus y. How am I going to move that 6? Subtract 6 from both sides. Good, because it's positive. And that gives me a negative 10 equals y. So x is 7. Y is a negative 10. So that's the algebraic way of getting that 7, negative 10 versus your graphing way, again, of getting 7, negative 10. So you have options. Okay. Very likely to be an inactive question, but you do have graph paper. All right, I love this question because it should be super easy, but it always stumps someone. That's fine. We wanted to stump us today, not on EOC day. A school opened with 100 students. The number of students has increased by 25% each year since the school opened. Which function can be used to determine the number of students at the school X years after it opened? I'll give you a minute to look at it and you give me your best guess, and then we'll discuss it. Anybody else? Got a good guess? Good. It is C. Awesome. So it has to be C. The problem with B is it's missing the 1 plus 0.25. They didn't give you an answer to really mess it up, but the other thing, remember, always our percentage is going to turn into a decimal. That means move the decimal 2 to the left or divide by 100. So 2 to the left or divide by 100. And then your starting amount, and so it's a growth or decay. So increased is a growth, so that's why it's a 1 plus, so 1.25 instead of 0.75. And then if we think about it, A is linear, so that's going to be linear. And that means that rate of change is going to be a quarter. 0.25, I always think about money. You got big old quarters. So you have 100, and then you get a quarter every time somebody shows up. That's not going to be a thing. Not to mention students don't come in quarters. You don't get arms and legs that show up to the classroom. So that'll be another reason if you can get in your head that mx plus b, that m is going to happen that same measurement every single time by addition or subtraction. All right, so moving right along to our next page. Factoring practice, because I know you and you will avoid it. You will avoid it, avoid. So here's your day that you have to at least sort of pay attention and hopefully learn it. All right, factoring practice number 1. What is wrong with this problem? Why can't we just dive right in and get to work? Do you remember? The negative 13x is a problem, exactly. So we need it in standard form. Standard form of a quadratic is ax squared plus bx plus c. Okay, so we're going to add, yes, perfect. We're going to add that 13x over. So then the equation we're actually going to be factoring is x squared plus 13x plus 42 set equal to 0. Now I can factor it, and then if I wanted to, I could go ahead and solve. Now, is a greater than 1? Is a greater than 1? No. Perfect. That's why your inside should say, yay, this is going to be super easy. These are the easy ones. So, just for the sake of if you got some not a lot of extra space in your brain, if you want to use the same one for everyone, just to show you it does work, I'm going to show you it still works. So a times c goes on the top, b goes on the bottom. And remember, we added a line when a is not 1, and that's at ax, ax. So what is the value of a? Whoop, I think I jumped you. What is the value of a? 1, good. And b is 13. And c is 42, perfect. A times c, so 1 times 42 is going to go on the top. B goes in the bottom every time, so that's 13. We said a is 1, so we're going to put 1x, 1x. Now, we have to decide what I can multiply together to get 42 that will add or subtract to give me 13. So I have 1 and 42, 2 and 21, 3, I do not believe, yes it does, 3 and something. 3 and 14. 42 divided by 4. Oh, that is not it. It's not a good one. 5 is no good. And then 6 times 7, like we talked about in our earlier problem. Which one of those pairs will add together to give me 13? Or subtract. Add or subtract to give me 13. Yes, 6 and 7. Good. Because 14 and 3 would give me 11 or 17, 23 or 19, 43 or 41. So that's no good. So 6 and 7. So 7, 6. Between the 6 and 7, which one's bigger? 7. Perfect. And is our b value positive or negative in that given equation? Positive. So that means 7 has to be positive. If I have a $7 in my pocket and I need to have $13 in my pocket, is 6 going to be positive or negative? Good. So then 1/7 can't be reduced. That's going to be x plus 7. And 1/6 can't be reduced. That's going to be x plus 6. Again, these are the factors. So if it says to factor, we're done. If it says to solve, does anybody remember what you do to solve? We're not going to do it today. Set it equal to 0, each one of them. So x plus 7 equals 0, x plus 6 equals 0. And then just solve for those x-intercepts. That's going to be a negative 6 x-intercept and a negative 7 x-intercept. X-intercept, root, solutions, zeros. Again, just trying to make sure we remember those vocabulary words. Looking at the second one, hopefully you identified already there's a mess. It's not equal to 0. This is a trick question. Be very careful. What would you move? Good. Okay, so we do not want to move the 3x squared. You can, but then you end up with other issues because your a value will be negative. If you can avoid negative a values, that's a beautiful thing. So try to avoid negative a values. And there's ax squared. So this is our a value. We want it to stay positive. If we can turn it into a 1, that's even better. We'll deal with that in a minute. So I'm going to move this negative 15 over. How am I going to move that negative 15 over? Add 15x. Perfect. And that 72, I want to move it. So how am I going to move it? Subtract it. So basically all of this becomes opposite. So 3x squared plus 15x minus 72 equals 0. Anybody else going, ugh, 72, that's such a big number. A is not 1. Boo. Does anybody remember the first thing I said to always check? Always, 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 always check. And I'm the worst at it too. When we're going to factor, if A is not 1, what do you hope you can do? Good. GCF, greatest common factor. So I always check that front number. Again, crossing my fingers, hoping that that can turn into a 1. Does 3 go into 15? Yep. Does 3 go into 72? Yep. Good. So we're going to take a 3 out, and we'll end up with x squared. 3 times what gives me 15? Tristan, this is your time, bud. What's 3 times what gives me 15? Good job. 3 times 5. And then 3 times what gives me 72? Or a negative 72. 3 times a negative 24 gives me that 72. Now, I'm just going to put that 3 on pause for a second. Now I have A is equal to 1. It's a trinomial, so we're going to go ahead back. And you can either do regular star or big star. AC's on top, B's in the basement, AX in the corner, AX in the corner, if you want to just be able to repeat the same process every time. In the parentheses, A is equal to what? 1. Perfect. B is equal to 5. C is equal to a negative 24. Excellent. So B goes in the basement. That's going to be negative 24. Oi, I'm messing up. I'm getting too excited. B goes in the basement. That's that positive 5. A times C is going to give me what? Good. Negative 24. Because 1 times 24. A is 1, 1x, 1x. So we're looking for the numbers I can multiply to give me 24 that will add or subtract to give me 5. So 24 to 5. You have 1 and 24, 2 and 12. Remember, again, if you don't remember your multiples and you have your calculator in front of you, if it's the active portion, we can do 24 divided by x. That x is right underneath mode, and then hit second graph, and you're looking for, whoa, sorry, earlier I was doing something totally different. Let's go with 0. There we go. 1 and 24, 2 and 12, 3 and 8, 4 and 6, 6 and 4. Yep, good. 3 and 8. You guys were better than me. Faster, faster, faster. So 8, 3. 8 is bigger than 3. Is my B value positive or negative inside this parentheses? Positive. So the larger one's going to be positive. If I have $8, but I need to have $5, what am I going to do with that 3? Add it or subtract it? Good. Subtract it, because then I'll have 5 like I need. This is that 5 I'm looking for. So then my factors are x plus 8 and x minus 3. Again, for those in the back, these are factors. And to solve, we would take each one, set it equal to 0, and then we would find our x-intercepts, our zeros, or our roots. All right. 2x squared minus 3x minus 9. First thing we always want to check for, say it again. GCF. Always check for GCF first. Smallest number is the best one to check because that's going to be your best bet. 2 does not go into 3. So we're in A is greater than 1 land. Sometimes some of you think that's no big deal. Others of us shut completely down. Don't shut down. We got to process. So we have our star, AC at the top, B in the basement, A times X in the corners. What's my A value? 2. Beautiful. What's my B value? Negative 3. Perfect. What's my C value? Negative 9. Excellent. Now, what is A times C? What is A times C? Negative 18. Perfect. Because that's 2 times a negative 9. Oh, good. You guys are all putting it in there. I love it. All right. And our B value is a negative 3. A, you just told me is 2. So I'm going to put an X beside it, an X beside it. So we're working on our list of numbers I can multiply together to get 18. That'll add or subtract to give me 3. Some of you, I think, are starting to already figure these out faster than me. 1 and 18, 2 and 9, 3 and 6. 4 is no good. 5 is no good. And then we're back to 6. Which pair can I combine to get a 3? Yep, 3 and 6. Perfect. 6, 3. 6 is the larger. Is my B value positive or negative in this one? Negative. So 6 is definitely going to be negative. I am in the whole $6, but I need to be in the whole $3. So do I add that other 3 or do I subtract that other 3 factor? Add, right? Because if I'm in the whole 6, I need to get where I'm in the whole only 3. So I need to put $3 at that negative 6, and then I'm sitting at negative 3. Now looking at our not fractions, again, just so you don't walk into another math class one day and be like, oh, this fraction. It's not a fraction, not fraction. But we're treating it, we're pretending like it is because we're cheating the system. Can 2 over 6 be reduced? Yes. What number goes into both 2 and 6? 2 goes into 2 one time, and 2 goes into negative 6 3 times. Don't forget your negative. Or our x. So x minus 3. 2 and 3, can it be reduced at all? No. Good. So then that one's done. 2x plus 3. And those are the factors. If all it says to do is factor, you're done. If it wants to know the zeros, the roots, or the x-intercepts, we'll set both those equal to 0. We'll be very careful on this one because it's a little bit different. And then we'll solve for x. What's wrong with this guy? The negative 3. We got to move it over. So what's going to happen to that negative 3? It's going to become a positive 3, right? So we have 7x squared plus 10x plus 3. Problem in paradise. Is there a GCF? Is there something that goes into 7, 10, and 3 other than 1? 1 doesn't really count for GCF conversation. 1 is a no good. So 3 does not divide into 10. 7's a prime number as well. Whichever way that you found that it won't work, that's all that matters. It won't work. So we do not have a GCF. So AC at the top, B at the bottom, and AX in each corner. So what's our A value? 7. Good. What's our B value? 10. And then last but not least, our C value, 3. I feel like you guys were typing it in the box waiting for me to ask and then hitting enter. So what is A times C? So what is A times C? 21. Good. And our B value is going to be 10. All right. And then our A with our X goes in the upper corners. We're building our ACB chart is what they used to call it at Pinecrest. So 21, it's going to add or subtract to give me 10. I bet you guys already know. I see it. You already typed it in. Whew. So 7 and 3. So we had our 1 and 21, 3 and 7, and that's it. 1 and 21 would give us 20 or 22, so that's no good. The middle term is positive, so 7 is going to be positive. If I have $7 and I need to get to $10, what do I do with that 3? Add it or subtract it? Add it. And when I say I need to get to $10, that's because of the 10 down here. Looking at this not fraction, does that 7 over 7 reduce? Yep. Become a 1 over 1. And again, this is where I say it's not a fraction matters because it doesn't disappear. You still have to have an x and a 1. Like we're still looking for 2 places. The top of the not fraction and the bottom of the not fraction still exist. 7 over 3 cannot be reduced. Nope. So then we're going to use it as is, 7x plus 3. And then you have your factors. Right? You have those factors. If we needed to solve, we would set them both equal to 0. Again, paying very close attention to this guy because it's not going to give me negative 3. Because there's that 7 in front of that x. Just calling out mistakes I've watched students make. Now, moving right along to the part that you guys should have worked on, will work on today, and will work on tomorrow, is identifying parts of the graph. I think this is cool because you have active portion of your test. And really, as long as you understand and you can visualize, you don't have to really solve for a lot of these. All right, so looking at our first one, we're going to look for the vertex. The vertex is that point where it turns. And that's 1, negative 2, 1, 2, 3. So that's going to be negative 2, 3. Remember, x value first, so left, right first, then up, down. Does this parabola have a max or a min? Do you remember? Have we picked up? I mean, have we memorized that yet? Okay. Is that a smiley face or a sad face parabola? Smiley, right? He's happy, smiling. If you're smiling, do you have maximum problems or minimum problems? Minimum problems. So smiley face has min problems. Sad face has max problems. Sad face, max problems. Okay? Ultimately, what it's saying, though, is that when it's a positive graph, it's going to go down to its smallest point, and then it's going to come back and get big again. So it goes down to the smallest point, its minimum number, and then it's going to get large again, just for discussion of math part. Same thing. It's going to go up, 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 stop, and then turn back down. So that's the maximum number, so biggest number that will work for that quadratic. But I like the smiley face, sad face, because I feel like that's easy enough, and, you know, we don't usually have to discuss it with anybody out loud. We just have to make sure we keep it in our head. So smiley face, minimum problems, sad face, maximum problems. They will ask, what is the min value? The min value or the max value is always your y value because, again, it's up and down, minimum and maximum. How tall, how low. So then that's our y value of our vertex. So in this case, the min is equal to 3. That's the smallest y value before it turns back around and goes the other way. So again, you're looking at your y value. So max for this guy, that's 1, 2, 3. So the max is going to be equal to 4. The max for this guy, 1, 2, 3, oops, it's exactly the same, is also 4. So min max is always your y value. Axis of symmetry, I always like to think about butterflies. Like when you fold it, a butterfly, when he folds up, he matches on both sides, right? So it's the line or the butterfly body if the parabola is the upper part or lower part of its wings. So it's whatever this line is. The axis of symmetry is always going to be an x equals equation, and in this case, it crosses at the negative 2. Maybe we see negative 2, 3, negative 2, 3. The x value of your vertex is always your axis of symmetry. Your y value is always your max or min. So if you can find your vertex, you can answer the max min, you can answer axis of symmetry. It's just remembering the axis of symmetry is going to be an equation, and a max min will be just a number, usually. Okay? Zeros are where it touches the x-axis. This guy has none. He does not touch the x-axis at all. He's sitting over in quadrant 2 just hanging out. Is this a positive graph or a negative graph? That guy should have probably been up there. So is this one a positive or a negative graph? Positive, right? Smiley face, positive, minimum problems. That means it opens up. Whenever I've just heard that verbiage where it says, does the graph open up or open down? Think about like opening a cereal bowl. That's another way people have taught min and max and happy face, sad face. If you have a cereal bowl full of cereal, you have minimal problems. You're not hungry. If your cereal bowl's upside down, trying to fill it with cereal is going to be max problems is another way. Y-intercept is where it touches the y-axis, which is going to be that 7. So 0, left, right, up, down, 7. Just for more like little fun, save yourself some brain power things. If you find the pattern, constant is always your y-intercept, whether it be linear, quadratic, exponential, any of those good fun things. The constant on the end will always be your y-intercept. All right, so go on to the next one. What's the vertex of this guy? Can you guys see it, or do I need to zoom in? So this is 1, 2, 3, 4. 1, 2, 3, 4. So our vertex. Yep, that's the equation we're looking at. Yep, the negative x squared plus 4x. The vertex, which is this point here, is how many to the right? Yep, 2, 4. Perfect. 2, 4. 2 to the right, 4 up. So our vertex, positive 2, 4. Our max is the y value of our vertex because he has maximum problems. He's sad. So that's that 4. Axis of symmetry, again, is always going to be an x equals. That's the vertical line that crosses through the vertex and splits the quadratic symmetrically. So it's going to be x equals what? 2. Good. It's the x value of your vertex. The zeros are another word for x-intercept, roots, or solutions. If I can make that go, edge relative still there. Sorry. So our zeros are the x-intercepts, zeros, roots, solutions. So it's where it crosses the x-axis. These guys down here. See, that's not really this number and this number. So we have 2 of them. And that's going to be at 0. So 0, 0. And then 1, 2, 3, 4. 0, 4. Oh, I did that backwards. 4, 0. We definitely went left, right. We did not go up, down. 4, 0. X-intercept, zeros, roots, solutions are all the same thing. Is this a positive or a negative quadratic? Negative. Perfect. And what's our y-intercept? Where does it touch the y-axis? 0, 0, the origin. And look, there's not a constant. It's missing, right? So that's at 0. 0, 0. There's nothing there. So that's how we know. If you want to look at the equation versus the graph. I'm a graph person myself. But no harm, no foul, as long as you get it right. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4. What is our vertex? Good. Over 3, up 4. It's a max because it's a sad face, and that max y value is 4. What is our axis of symmetry? It's an x equals 3. Good. If I should draw that vertical line, it's going to cross right through 3 because that is a line. X equals a vertical line, so x equals 3. Zeros. Where does it touch the x-axis? What are my zeros, x-intercepts, roots? Where does it touch? One and so 1, 0 is one of them. So that's this guy right here. But it touches again here. Yeah, and 5, 0. Perfect. Perfect, perfect. Is that a positive or negative quadratic? Negative. Excellent. And what is my y-intercept? We don't know. I just set you up. Sorry, I put this together really quickly because I couldn't combine 2 other worksheets. Our y-intercept, yes, you do. Maybe you do know. What is my y-intercept? Negative 5. Good, from the equation. Excellent. 0, negative 5, because again, your y-intercept is that constant. Because, ooh, we're done. That's all the time I got. Never mind. If we had factored this equation, that negative x squared plus 6x minus 5, if you took a negative 1 out and then factored it using our star, you should have had an x minus 1 and an x minus 5 for our factors. We have a positive 1 solution and a positive 5 solution. That's more of one of those skills that's going to pay off huge if you find the pattern early, but huge in Math 3. All right?